effective of voltage RMS value. Let us see here. This is the formula for Vrms is equal to Vm by root 2. When you do this, what happens? You will get the value of Vrms. So 700 by root 2. Let us see. Is it 700 by root 2 is correct? So I write 700 divided by what is the value of root 2? 1.414, right? 1.14. So I get 495.049. Okay. So there is some little change in the calculations. 495.495 is the answer actually. But let us use the scientific calculator, and I will just find out here the value of 700 divided by square root of 2, right? So where is the square root of 2? Yeah, square root of 2 is nothing but x power, oh sorry, 700 divided by root 2. No, not this. 700 divided by 2 to the power of, okay, root 2 means half, 0.5. No, I think just not used it properly. 700 700 divided by 2 to the power of, okay, root 2 is 1 by 2. 1 by 2. Let me just find the value of root 2. 2 to the power of 1.4142. Okay, I just 1.4142. So 700 divided by 1.4142. So 494.97. Yeah. So I got this value 497.97 here. Okay. Now what is a phase shift? Phase shift is the value of phi. You see, this is the phase shift, as I have told you. Phi is the phase shift. So theta is 15 degrees. So just we write from here. Okay. Theta is 15 degrees. Phase shift is how much? 15 degrees. Okay. Now next value is about the frequency. Now what is the frequency? The frequency is nothing but f. Okay, so we know the formula omega is equal to 2 pi f. From that we know that omega is 1085 from the previous equation. You see here from this slide, this is omega. Omega is 1085, right? So I write 1085, omega is 1085, omega is equal to 2 pi f. F is equal to omega by 2 pi. Omega is 1085 into 2 into 22 by 7. So this is this 7 will go up. So 1085 into 7 by 22. So again use the calculator and just verify that our results are correct or not. Okay. So I think we can use normal calculator here. So I use 1085 into 7, okay, divided by 2 into 22. Okay, so when I just hit it, I get the answer as 172.61. Now 172.61 is the magnitude, but the frequency unit is hertz, so that's why I write hertz. So the frequency is 172.16 hertz. Okay. Now let us find out the angular frequency now. Omega, which is already 2 pi f. 2 pi f is nothing but 1085 radians per second. So see, the angular frequency unit is radians per second. This is very important. Okay, radians per second. So total frequency is 1085 radians per second. Periodic time, the next part is periodic time t. T is 1 by f. So 1 by 172.67 hertz. So this is the periodic time. The formula for periodic time is 1 by 172.61, which is t is equal to 5.79. Okay, this is milliseconds. This is the periodic time we got it. Okay, so by this we have solved first problem. So remember, from the sinusoidal equation, you need to get only Vm. From Vm, for sinusoidal signal, okay, we get Vm. From Vm, you can find out maximum voltage, you can find out average voltage, effective voltage, phase shift, the angular frequency, the frequency, the period. Okay, so by this we have finished the first question. Do you have any questions? Yes, any questions? Please ask. Anyone of you have any questions? Okay, I got one question. Let me see. Okay, no. So there is no question. It means you have understood. Great. So now let's go to problem number 2. Okay. So shall we proceed to problem number 2? All of you. You have any question? Ask me. Then otherwise, I will go for the next problem. Okay. So any answers? Please tell me. Shall I move to next part? Any answer? Shall I move to next part? If you have any questions, ask me. No questions? Nobody's answering. Ahmed bin Hussein bin Mohsin, Thamir Mafla, Hassan bin Ali, Ziad bin Hassan, Abdurrahman, Umar Zafar, Faris, bin Wasmi. Nobody is answering me. Shall we go to next point? Okay, great. So see, I want my class to be two-way communication. Okay. So when I ask any question, please respond me. Okay. So let's go for problem number 2. Okay, the current flowing through a I will just use highlighter. You see, the current flowing through a inductor. How much this inductor? 100 millihenry is the inductor, and the current is 2 sine 377 t amperes. Now you have to find out voltage across the inductor. How do you find out the voltage across the inductor, and how do you find out the expression of energy stored in the element? Okay, these are the few important questions which you need to understand. Okay, so before that, let me give you some important point about an inductor. What is an inductor? Inductor consists of a coil of conducting wire. Okay, it is a property whereby an inductor exhibits opposition to the change of current flowing through it, and its unit is Henry. Okay, see this H. Do you see this H? This is the unit of inductor. This is called Henry. Now you can have the equations for inductor. That voltage across the inductor can be written as I just write with the ballpoint. Okay, V is equal to V is equal to L. L is the inductor into di by dt. This is dt. Okay. V is equal to L di by dt. So from this you can take di is equal to V dt into L. Okay, V dt divided by L. So from this you can find out that di, just do cross multiplication, is equal to this di is equal to V into dt, V into V into dt 1 by L. Okay. And if you want to find out only current, you apply integration both sides. When you perform the integration both sides, this d and this integration get cancelled, so I is equal to 1 by L. Okay, 1 by L 0 to t vt dt. Okay, and energy stored, there is another formula. Energy stored in the inductor is given by omega is equal to half. This is the formula, half Li square. Li square. Okay. So maybe I don't write properly because I have to write with mouse. I don't have any touch pen to do that. So please bear with me. So now let us solve the problem number 2 now. The current flowing through an inductor is I of t is equal to sine omega sine 2 sine 377t amperes. We have to find out first voltage across the inductor. Okay. Now voltage across the inductor, just now I have told you what is the formula. The formula is this: V of t is equal to L di into dt. Right? I think you remember. You see, V is equal to L into di into dt. V is equal to L into di into dt. This formula. Now, according to this formula, what is given in the problem? You see, this is L is given. This L is given. L is 100 milli and I of t is given. So two values is given. L is given is 100 millihenry and I of t is given in amperes. Okay. Now we have to find out V of t. So let us put these values. L is 100 and I of t is 2 sine 377t. So I put these values in equation. Suppose this is equation 1. So I put all these values in equation 1. I get V of t is equal to L means 100 into d by dt of 2 into sine 377t. Okay. Now you have to find out the differentiation of this point. What is d by dt of 2 sine t? Now I want answers from the audience. Now tell me what is the derivative of 2 sine 377t? See, 2 is a constant. Okay, so constant will come here. 100 into 2, it will be 200. Okay, now you have to find out only d by dt of sine t. You know that's d by dt of sine ct. C is some constant like 377 here. Then d by dx of sine x is what cos x d by dx is okay minus sine x. Okay. You know this formula from the fundamentals. So you see here I write in v of t is 100, but what is this 100? This 100 is millihenry. Okay, so I write millihenry. Then this 2 is coming here. Okay, then d by dt of sine t is nothing but cos t cos 377 into 377, right? So that's why I have 2 into 377. So this 2 is coming from here and this 377 is coming from here. Okay, so now milli is nothing but zero point 0.1 here into 2 into 377 cos of 377. Okay, so now when you simplify 0 0.1 into 2 into 77, let us see what you get. 0 0.1 into 2 into 377, you get the answer is 75.4. So that's what you got here. Okay, 75.4 cos 370 volts. This is nothing but the voltage across the inductor. The voltage across the inductor. Okay, so now the another part B, you have to find out the expression of energy stored in the element. We need to find out the expression of energy stored in the element. Any questions? Okay, no questions. Yeah, tell me if you have any questions, please ask. Yeah, any questions? No? Okay. So I go to my part then. the expression of energy stored in the element. Omega is equal to half Li square. Okay, L is given already. We know that zero point 0.1 Henry. Okay, this unit is in Henry H. Milli is 10 per minus 3. Okay, current is given as 2 into sine 377. This is ampere. A. Okay, so these writing units are very important. Now let us put these values in this equation. Omega is equal to half L is zero point 0.1 into sine square 377t. Okay. Now I ask all of you, please use your calculator and tell me what is the answer now. Okay, what is the answer? I have to write this. Omega is equal to, okay, how much is it? Half. This is 1 by 2 into, okay, 100 means 0 0.1 milli. Milli means 0 0.1. Okay, L is this into 2 sine 377. Okay, 377. You just run like this. You see, half 100 into milli is 10 power minus 3, 277 whole square. Okay, we have written like this. Okay, so when you write like this, so omega is equal to this 0.1, okay, by 2 into 2, 4 by sine square 70. Now tell me what is the answer for omega? Anyone? 0.1 into 4 is 0 0.4 by 2 is 0.02. 0.02 sine square 377. Okay, so please solve it and write. I have not written it. I didn't solve it. Okay, you have to solve and write the equation here as 0 0.2 sine square 377t. Write these values here. Sine square 377t. Okay. Good. The answer Yasser has given as 0.017. 0.017? No, brother. How is 0.017? 0.4 by 2 is 0.2 only. You see, look here. You have 0.1, 0.1 into 4. It's 0.4 divided by 2 is 0.2 only. So you get 0.2 sine square t. Okay. Similarly, 1.709. No, how you get these values? You see, you cannot find out for the value of sine square 377t because you don't know t. Okay, so you know these values. This value is 0.2 sine square 377t. Solution. Okay, so 0.01 and 0.7 is it's not okay. Okay, so please, the answer is 0.2. Okay. Yeah. So let's go for the next problem. This is problem number 3. Shall I move for next problem? Shall we go for next problem? Or you have any questions? Please ask. No questions. We'll proceed for the next problem. Okay, great. Thank you. So great. Now let's go for third problem. The voltage across 120 microfarad capacitor is given by V of t is equal to 380 sine 317t volts. Now we have to find the current through the capacitor and also the expression of energy stored in the capacitor. Now here also you need to remember the formulas for the current through the capacitors and the energy stored in the capacitors. The current through the capacitor is given by I of t is equal to C into dV of t by dt, where C is the capacitor, and the expression of energy stored in the element is given by omega is equal to, or W is equal to half C V T square, V square T. Okay. So let me write, then you'll understand. So before I go for something called capacitor, I want to give you some information about the capacitor. Well, in DC, we have what do you mean by actually capacitor? What is capacitor? Any answer? Any answer for capacitor? What is capacitor? Capacitor is, why we use capacitor? For storing charge. Okay. So no answers, no problem. So let's go for capacitor formula. No. So the current through the capacitor is given by, you see, the current through the capacitor is given by the formula I of t is equal to C dV of t by dt. Please remember this formula. This is very important formula. I just highlight this. You see, this is very important formula. This is for current through the capacitor. And previously we saw that voltage through the inductor is V of t is equal to L di by dt, right? And here current through the capacitor is C dV by dt. This is changed. C is nothing but the capacitor. C is nothing but your capacitor. Now the capacitor, even previously you see here, the capacitor is given as 120 microfarad. 1 micro is 10 to the power of minus 6. So C is 120 into 10 to the power of minus 6 farad. This is given. Okay. Now I of t is equal to, you have got C is equal to 120 into 10 to the power of minus 6 F. Now how do you find out V of t? V of t, this is given in problem already. You see, this is given in swat. In question, it is already given. Look here. See, in question already has given V of t. Okay. So we have to use this equation and put the given values. So see, now what is the formula? Let's put here. I'm putting using this equation. I of t is equal to C. What is C here? C is 120 into 10 to the power of minus 6. Okay. d by dt of v of t. What is v of t? This is v of t. This entire is v of t. I put d by dt of v of t. 380 sine 377 t. And now, can any one of you solve and tell me what is the value of I of t in amperes? Tell me. Any one of you, please solve it. D by dt of sine, use this 380 is a constant. It will come out of these brackets. Okay. And you multiply this 317 with 380 and sine will become cosine. Okay. So you see 120 into 10 to the power of minus 6 I have written as it is, and 380, which is a constant, come here. Then the d by dt of sine t is cos t into 317. So you just multiply all these terms and tell me, is the answer correct? Please tell me, is the answer correct? 14.45 cos 317t ampere. Is it ampere or micro ampere or milliampere? Can you tell me how much is it? Let's calculate. 20 into 10 to the power of minus 6, okay, into 380. I think I got some answer. Let me check. 317. Any answer? Yeah, 14.4552. 14.4552. Very good. So you got the answer as, okay, this one. Yeah, good, very good. Excellent answer, good answer. So this is the solution. We got the answer. Now the next part is B. You have to find out. Okay, welcome. Let's find out the expression of energy stored in the element. Okay. Now omega is equal to half CVI v square, half CV square. Okay. Now here you know that C is already given as 120 microfarad and V of t is given as this. Now can any one of you solve and tell what is the value of energy now? Okay. So please solve and tell me what is the value. You just write down omega is equal to, see, omega is equal to half CV square. C is 120 microfarad and V of t is 380 sine 317 t amperes, sorry, volts. Omega is equal to half. This is C, okay, and this is V of t square. Okay, so 380 whole square sine square 380. Now please solve and please tell me what is the answer. Solve this and tell me. I'm waiting for your reply. Answers. Let us see who will do it first. Any answer? Half into 120 into 10 to the power of minus 6 into 380 square. You need not solve sine square 370. Let it be same. You need to just solve only this part. This numerical part, you solve it and tell me how much you get. .28. Ziad has given one answer, 2.28. But unfortunately, I think you need some corrections. So half, when you solve it, you get omega is equal to 8.66. Okay. The correct answer is 8.66 or sine square 370. Now the unit of energy is joules. Yeah, great. So the answer is 8.664 sine square 317 t joules. Okay. Now for the today's session, I think there's enough. 3 problems are enough. Now what you have is all of you go to your course and click on this online classes. Okay. When you click on this online classes, okay, you will find the activity 1 here. Okay, click on this activity 1, then activity 1 will be started in superposition theorem and you need to solve this activity and then we'll finish our lecture. Okay, you can leave the session after finishing this activity. So I kindly request all of you to go to your course and click on this online classes. In this online classes you will see activity 1. So click on this activity 1. Then when you click on this activity 1 gets opened. Here you can begin your activity. Okay, so all of you please do this. Before doing this, let me just see if you have any questions. Any one of you? Any questions? Please ask me. Yeah. No questions? So, okay. Okay, great. So nobody has any questions. Now, all of you, please don't log out from the session. Being in the session, you have to go to that online classes and then complete the activity 1. Okay. So I'll be watching you here. Please go and open the activity 1. Yes, quiz is starting now at 4 p.m. Okay.